Okay, here's a lesson on combinations and permutations. So, um, combinations and permutations are ways of figuring out all the different outcomes you can have when you are arranging things or you're putting things together. So, this goes along in our probability and statistics unit because it is often used to calculate probabilities of certain outcomes happening. And so the difference between a permutation and a combination is really just whether or not the order that you're arranging them matters. So, for example, if I had 15 players on a basketball team and I'm trying to figure out the ways that I can put a starting five out on the floor, order here wouldn't matter because it doesn't matter who's selected first, second, third, or fourth, or fifth. You're just putting a starting five out there, and it doesn't matter which order they come in. It's the same starting five. So that's a situation where order would not matter. But oftentimes, when you are putting them in specific places or specific positions, or if they're like in a race, if they're going to be coming in specific positions like that, then order will certainly matter. So a permutation is an arrangement of objects where order matters. And the key word there is order, or keywords is order matters. So when you are trying to make arrangements of certain things and order matters, then we use what is called a permutation. Now, we're not going to get too much in the detail here, really just basically going to show you how to use it in your calculator. But we've done problems like this before where we've actually written out all the different arrangements. So a particular situation, could have been the problem we did before where, there's certain questions on a test and, what is, all the different outcomes you can have with a 4-question quiz that's true or false. Like what are all the different ways that you can score on that test? And so that's a sample of, we wrote it out, but sometimes the arrangements can be complex and they can be very large, and we wouldn't want to write them all out to figure out how many there are. So we can use a permutation or a combination to quickly calculate the number of ways or arrangements that you can have. So here is an example where, pretty simple, it's asking you how many ways can you arrange the letters of the word July. So you have a J, a U, an L, and a Y. And so how many different ways can those be arranged? And so in this particular one, order matters because you're putting a letter first, then you're putting a letter second, then you're putting a letter third, and then a letter fourth. So the order does matter here. So in the old way, you would just say, okay, well, how many different, ways can I arrange the first letter? Well, since there are 4 letters, when you're going to put the first letter, you have 4 different choices. And then once that letter is used, the letter can't be used again. So when you go to the second letter, you now have 3 choices. And the third letter would have only second choices, and the first or the last letter would only have 1 because there's only 1 letter left. And so to calculate how many different arrangements there are, you simply just multiply all of these numbers. And so 4 times 3 times 2 times 1 turns out to be 24 ways. So there are 24 different arrangements of the word July. And so what you are seeing here is actually what is called a factorial. So this is actually 4 factorial. And before we move on to the second example here, I just want to show you what a factorial is. A factorial, some number with this exclamation point afterwards, is called a factorial. And what that means is it's whatever the number is times the number minus 1, then times the number minus 2, times the number minus 3, and so on. So for example, like 6 factorial would be 6, and then times 6 minus 1, which is 5, times 6 minus 2, which is, oh my gosh, 4, times 6 minus 3, which is 3, times 2, times 1, and that would equal, I believe, 720 if you multiply them all out. But your calculator can quickly do this. So for example, if you had a factorial that was 10 factorial, you wouldn't want to sit there with the calculator and go 10 times 9 times 8 times 7 times 6 times 5. So when you're doing this, you can simply type in your calculator. So I'm on the left side of the screen now, 6 factorial. You can type a 6, and then what you do is just go to the math button and scroll over to probability. And what we see here are permutations and combinations, but then also the exclamation point. And so 6 factorial is just 720. And so sometimes that is much easier to do. So in the example that's up here, you may want to just do 4 times 3 times 2 times 1, because it might be just as fast. But sometimes it's easier to use the factorial button in your calculator. So here's another example where you're only going to use 2 letters. So I still have the word July, so July, but I'm only going to arrange them into 2 letters. So for the first letter, you still have 4 letters to choose from, and the second letter, you still have 3 letters to choose from. But then that's it. Because you're only making a set of 2 letters, you only need the first 2 pieces of the factorial, which is 4 times 3, which is 12. And so here's where it gets complex. Is remember the basketball team, there are 15 players on the team, but I can't just simply do 15 factorial because all 15 players can't be on the court at the same time. I can only play 5 at a time out of the 15. And so this is where a permutation is necessary, because it's not necessary. It just, the calculating it in a way, instead of writing out all the different outcomes, is a lot easier using the formula. The permutation formula is whatever, I'll just write the formula, NPR, that's supposed to be a lowercase r. So NPR, where N is going to be the total number of choices, and R is going to be number of choices being arranged. Now, I'm not going to go into the actual formula. The actual formula is a little bit more complex than this, but since we're just going to be using our calculators, I'm going to show you how we do it in the calculator. So let's look at a couple of examples here. So here you have 10 horses that are running in a race. How many different ways can the horses finish first, second, and third? First of all, we have to understand that order matters here. Order matters because there's someone that's going to place first, then second, then third. They're not just randomly selected to finish first, second, or third. They are finishing in specific positions. So order does matter here. So we know we're going to be using a permutation. So again, you want to look at what's the total number of choices here. Well, there are 10 horses, so I write 10. And then I have the P because we're using permutations. And the R is the number of choices that are being arranged. Since it's first, second, and third, there are 3 choices that are being arranged. And so our calculator, we can go to the same place, so math over to probability, and you'll see the NPR there. And what this does is it allows me to plug in the N and the R and then just hit enter. And so we see, coincidentally, this is also 720, but it's 720 different ways that the 10 horses can finish first, second, and third. And so, number 2, you have 8 people serving on a committee. How many ways can a chairperson, recorder, and treasurer be chosen from the committee members? Again, order matters here because these are specific positions. They're not just taking 3 random people and throwing them together. There is a person that's going to be the chairperson, one person that's going to be the recorder, and one person that's going to be the treasurer. So order matters, so we're going to be using a permutation. So again, total, P, and then how many you're arranging. Here the total was 8, P, and then the arranging, you're arranging it to 3 different positions, so 3. And so we'll put this in our calculator. So math, probability, NPR, and so 8P3 enters 336 different ways that you could have a chairperson, recorder, and treasurer out of 8 people. Now, up here, permutations is where order matters. Well, in combinations, order doesn't matter. So this is, for example, like if like the basketball team example where, I'm just throwing 5 people out there. It doesn't really matter who's first, second, third, or fourth. I'm just, going to put them out there. And so order doesn't matter in that particular case. Or if, I was, going out to eat, and, there was options for sides or something like that. It doesn't matter. If I get 2 sides, it doesn't matter which is first or second because I'm going to get the both sides. And so sometimes order doesn't matter. And so in this case, oftentimes the amount of different ways is less than a permutation because a combination is very, very specific because order matters. But with combinations, since the order doesn't matter, a combination can take up a lot of different permutations. So these numbers will tend to be smaller. So here's an example where you count the possible combinations. And also one thing to heads up is oftentimes with combinations, it'll actually tell you that it's a combination. So if you don't figure it out right away, sometimes it's a dead giveaway. It actually tells you that it wants you to find the combinations. So here, 2 letters chosen from A, B, C, and D. Combinations are done exactly the same way. So it's the total. The only difference is you're going to be using C instead of P. So the total here is A, B, C, D. So I have 4. That's a total, but I'm going to use C instead. And I'm arranging it into 2 letters. So we can do 4C2. So math, probability. You'll see C there. So 4C2. And that is 6 different combinations from with 2 letters using A, B, C, and D. Now I've already given you the formula, so I'm not really going to fill anything there. So let's look at some examples of combinations. So here's that side problem here. So if you order a sandwich at a restaurant and there are 8 sides and you're going to be choosing 2 sides, order doesn't matter here because it doesn't matter which side comes first. You're going to have both of them and eat both of them. So order doesn't matter here. So we want to do 2 sides from a list of 8. So 8 is going to serve as our total, and we're doing arranging 2 sides. And so when you do 8C2 math, go 8C2. Oh, don't want to do plus. It's 28 different combinations. One thing to note here at this point, sometimes you may get these backwards and you'll put the 2 here and the 8 here. Just want to show you what happens when you do that. So if I put 2 and then 8, I get a 0. And so the reason why you get a 0 is because you're asking the calculator you're telling the calculator that you have 2 options for sides, and how many ways can you arrange 8. If you only have 2 sides and you're trying to arrange 8, then the calculator is going to say, well, there are no ways that that can happen. There's no way you can arrange 8, only choosing 2 sides. So just so you know, if you get a 0, certainly 0 is a possible answer. But if you do get a 0, I would double check and make sure it's typed in correctly. That you have it right. It should always be the bigger number. The bigger number should always be first. So let's go back here now and look at the second problem here. You're listening to music. You have time to hear only 3 songs from a playlist of 16 songs. How many different combinations? Again, they're telling you that it's combinations. They did it in the previous problem too. How many combinations? So that's a dead giveaway that you're using combinations here. But you have 3 songs to hear out of 16. It doesn't matter what comes first, second, or third. You're hearing the 3 songs. So here the choices are, the total choices are 16 songs, and I'm going to be choosing 3. So we'll do math, probability, 16, and 3. So that's 560 different combinations of the 3 songs. The last problem we're going to do, we're not going to do this last one here. It's a little more complex than you guys need to have, so I'm just going to cross that out. The last problem here is for you to determine whether it's a combination or permutation, and then solve it. So here is an example where you have a yearbook that is selecting 14 photos, and that includes one of you and one of your friend, to use for a collage in the yearbook. The photos are placed at random, and there's room for 2 photos at the top of the page. So here, your photo and your friend's photo are 2 of the 14 photos that are going to be in this collage. So first you have to ask yourself, does order matter? So if there is room for 2 photos at the top of the page, and that's where you want to be, does it matter if your friend is in position 1 and you're in position 2, or you're in position 1 and your friend's in position 2? I would say no. It doesn't matter the order. As long as you're both at the top of the page, that's all that matters. And so this is actually going to be a combination. So to find the probability that your photo and your friend's photo are in those 2 spots, you have to first calculate how many different combinations can there be in those 2 photos at the top of the page. So what we do is we're going to create a combination. So there are a total of 14 photos, and you're going to be choosing 2. So that's the first thing we're going to do, is do 14, 2. So 14, C2, enter. So I have a total of 91 different ways that the top of the page, those 2 photos, can be arranged. So in order to find the probability that you and your friend are at the top of the page, you have to remember that there are 91 different ways to arrange those top 2 photos at the top of the page. And only one way will have you and your friend at the top. So if there are 91 ways to set the top 2 photos, and only the combination of you and your friend is only one of those combinations, then it makes the probability easy to calculate, because then it's just 1 out of 91. Because you and your friend at the top of the page is just one of the 91 combinations that are possible. So the probability of them choosing you and your friend is 1 out of 91. So that's it. Let me know if you have any questions.